The OSPF link state database gets built with information from all the different routers within an area. This information is sent as LSAs, link state advertisements, and those link state advertisements are sent inside of LSU link state update packets. And when we're talking about LSAs, we need to understand they're of different types, and it's important that you understand the different LSA types we're going to be talking about in this video. And let's start our discussion of LSA types with this basic topology, and then we're going to build onto it a little bit. Here we've got a couple of OSPF areas, and we learned that the name that we give to a router that has an interface in more than one area, that's called an ABR, or an area border router. But within each area, Area 0 and Area 1 in this case, we have a link state database for each area. So the ABR, it actually has a couple of link state databases, one for Area 0 and one for Area 1. Let's talk about how LSAs are used to educate everybody in an area about the networks available in that area and in other areas. To begin with, let's talk about a Type 1 LSA. That's called a router LSA. If a router is connected to a network, and we assume it's connected to at least one network segment, otherwise it's not going to be talking to any other routers, but a router is going to use Type 1 LSAs to advertise directly connected networks. So in this case, R1 is going to be advertising that link between itself and R2. R2 is going to be advertising the same thing, but everybody knows it's the same link. So we're going to have a single Type 1 LSA in our link state database representing that link between R1 and R2. Same thing in Area 1. We've got one LSA Type 1 representing the network between R2 and R3. By the way, notice that there's sort of a lightning bolt icon between R2 and R3. That indicates a WAN link, and specifically I want you to know that I'm representing a point-to-point WAN link. And on a point-to-point link, we do not elect a designated router, a DR. That's something that we do on broadcast networks like Ethernet networks. We elect a DR and a backup designated router, or a BDR, but on that point-to-point WAN segment, there's really no point in electing a DR because there's no issue with forming a full mesh of adjacencies. And the reason I emphasize that there's no DR on that segment is that having a DR on a segment is one of the criteria for generating a Type 2 LSA. We're going to have a Type 2 LSA to represent every network segment within an area if that network segment meets two conditions. Condition one is the network has to be a transit network. In other words, it's interconnecting a couple of OSPF speaking routers. It's not just going off to a switch and connecting to end users, but it's linking together a couple of OSPF routers. The other criterion is that there be a DR elected on that link. Now, we're assuming we have some sort of Ethernet interface, like a gig Ethernet interface, coming out of R1 going over to R2. So a DR would be elected there. But remember, a point-to-point WAN segment like we have between R2 and R3, not going to be electing a DR there. So there's no Type 2 LSA to represent that one link between R2 and R3. Next up, let's talk about a Type 3 LSA. And I think a Type 3 LSA has an unfortunate name because I think it can lead to some confusion. Specifically, I mean that a Type 3 LSA is called a summary LSA. And oftentimes in networking, when we hear the word summary, we think of network summarization. We look at all these networks and we say, hey, they've got the first 19 bits in common, for example, and we'll advertise just one network with a 19-bit subnet mask. That is not what we're talking about here. In this context, a summary refers to summary information. Remember, within an area, we know about how every network, every router is interconnected with another. We're able to run the Dijkstra algorithm on this very detailed map with cost of all those links, but we might want to get to a network in another area. Do we need a map of that other area? No, that would kind of defeat the point of having another area to break up the link state databases. So instead, we're going to have the area border router send summarized information. Instead of saying, here's a map to Area 1, R2 is going to tell all the routers in Area 0, here is a listing of networks in Area 1. So we're not giving any sort of a detailed map. We're saying, here's a list of networks available in Area 1. And if you want to get to one of those networks, come to me and I'll forward you on to that network. And for every network we have in an area, there's going to be a single Type 3 LSA that's sent into the other area to advertise that network. But let's say that this is the network of a company that merges with another company. And this other company, instead of running OSPF, maybe they were running EIGRP. This is the network of a company that merges with another company. And this other company, instead of running OSPF, maybe they were running EIGRP. And we need to connect into that autonomous system. Well, a router that connects between autonomous systems is called an ASBR, an Autonomous System Boundary Router. And we're receiving all these EIGRP networks coming in from the EIGRP cloud, and R1 is going to advertise each of those EIGRP networks with a Type 5 LSA. So it's going to send all these Type 5 LSAs into Area 0, but when R2 advertises those Type 5 LSAs into Area 1, it needs to include an extra piece of information. For example, R3 sees a Type 5 LSA and R3 says, yeah, I'd really like to go to that network, but I don't know what IP address is going to get me out of my autonomous system into that network. So R2, since it does know about the ASBR, it's sharing an area with the ASBR, R2 is going to send a Type 4 LSA. A Type 4 LSA is called a summary ASBR LSA. That says to another area, hey, here is how you get to the ASBR. Here's the IP address of the autonomous system boundary router that you'll need to communicate with if you're wanting to reach one of those networks I just advertised to you with a Type 5 LSA. But as we look at this, we might be concerned that there are a lot of EIGRP routes being flooded into our OSPF autonomous system. Instead of having all those Type 5 LSAs go into Area 1, we could look at this topology and say, well, really, if anybody in Area 1 wanted to get to an EIGRP route, all it would have to do is go to R2, and R2 would get it there. So instead of sending all those individual Type 5 LSAs, what if we do this? What if instead we send a default route using a Type 3 LSA? We can say, if you don't know explicit information about how to get to this network, go here. So R3 is going to say, I don't have explicit information about how to get to this network that lives in the EIGRP autonomous system. I haven't learned about it via one of the Type 3 LSAs coming from Area 0, so I'll use my default route that I learned via this Type 3 LSA, which is going to get me over to the ASBR and out to EIGRP. I mean, there's no other place to go. It must be out there if I don't have that network learned locally or in Area 0. So if we do that, we eliminate the need to flood all of those Type 5 LSAs into Area 1. And even the Type 4 LSA doesn't need to go into Area 1. Instead, we're going to send a Type 3 default LSA. And this is called a stub area, implying that this area is just hanging off of the OSPF backbone area, Area 0. It's not connecting us to any other areas. It's not connecting us to any other autonomous systems. It's just kind of hanging off on the edge. It doesn't get us anywhere else. And in this stub area, we're still receiving individual Type 3 LSAs from networks in Area 0. A lot of people miss that. Make sure you hear me on that. That if we had 10 networks in Area 0, we would be sending 10 Type 3 LSAs advertising those networks. In addition to those 10 Type 3 LSAs, we would still be sending the Type 3 default LSA representing all those EIGRP routes. And this is a stub area. But if we think about it, if this stub area really only has one way to get out to the rest of the world, including Area 0 networks, why don't we just send that single Type 3 default LSA? That's going to reduce the number of Type 3 LSAs that we need to flood into Area 1. And if we do that, this stub area becomes a totally stubby area. Now we're sending this default Type 3 LSA into Area 1 saying, if you don't have it in your area, go here. But let's take this concept a step further. And to do that, let's back off just a little bit. Let's go back to where we had a stub area. Remember, we're sending individual Type 3 LSAs from Area 0 into Area 1. Let's say we had a stub area, and then we had another company merger, and R3 connected to a network that was running RIP as its routing protocol. So now R3 has become an ASBR, and this previously stub area is no longer very stubby. In fact, it's literally called a not so stubby area, or NSSA for short. But there's a rule with a stub area, and that rule is thou shalt not send Type 5 LSAs into a stub area. Remember those type 5 LSAs? Those are AS external LSAs. We send one of those for each network in that external autonomous system. And since we're not allowed to send type 5 LSAs into Area 1 from R3, I think this is sort of cheating personally, but here's what happens. R3 says, I've got all these RIP routes, and I'd like to send them into Area 1 using type 5 LSAs, but Area 1 is that pesky stub area. So how do I do that? Because I'm not allowed to send type 5 LSAs. Oh, I know. I'll still send the information, but I'll just call the type 5 LSA something else. I'll say they're type 7. That's it. Type 7 LSAs. Isn't that cheating? I kind of think it is. But it sends those network advertisements into Area 1 using type 7 LSAs. And those go over to R2, and R2 says, yeah, I see what you're doing. These are networks in another autonomous system. They should be advertised with type 5 LSAs. So R2, as it takes those RIP networks and sends them into Area 0, it says, I'm going to take those individual type 7 LSAs and I'm going to send them into Area 0 as type 5 LSAs like they should have been to begin with. And of course, we have to send information about how to reach R3, the autonomous system boundary router. We have to send that into Area 0, so routers like R1, they would know how to get to those RIP routes. But remember, we took a step back to a stub area, and with the stub area, we still have the issue that we're sending all those individual type 3 LSAs for Area 0 networks into Area 1. Well, let's make it a little bit better. Let's get back to where we had a totally stubby area, where we just send a single type 3 default LSA. But what does that do to our not so stubby area? Well, if we combine our individual type 3 LSAs into that single type 3 default LSA going into Area 1, we now have, not making this up, it's called a totally not so stubby area, a totally NSSA. And that's a look at the different LSA types you might see in an IPv4 network. Now, to get a better handle on this, let's go out to some live gear right now, and let's look at the link state database in a router and see if it matches what we predict will be in that link state database. Let's take a look at the topology on screen and see if we can predict the different LSA types that are going to be present in the OSPF link state database of router R5. Router R5, it is not an ABR or an ASBR. It's just sitting inside of OSPF Area 0. But we do have another area, so we'll be getting some type 3 LSAs from Area 1. And we have EIGRP as another autonomous system, so we'll probably be getting some type 5 LSAs from EIGRP, and we'll probably get a type 4 LSA telling us how to get to the ASBR, which is R2. Well, let's take a look. Let's go through the LSA types one at a time. First of all, how many type 1 LSAs are we going to have, those router LSAs? Well, in Area 0, there are only two segments. The segment between R4 and R5 and the segment hanging off of R5. So I expect to see two type 1 LSAs. What do you think about type 2 LSAs? Well, to be a type 2 LSA, you had to be a transit network, so R4 to R5 would qualify, and R5 out to that switch SW2, that would not qualify. Even though DRs would be elected on both segments, there are two criteria. It has to be a transit link, and it has to be a link on which a DR would be elected. So I'm expecting we'll see one type 2 LSA. And type 3 LSAs, those summary LSAs, that's going to be an announcement of a network available in another area. Area 1, specifically R4, our ABR, is going to report to us that there are two network segments in Area 1. The segment between R2 and R3 and the one between R3 and R4, so I'm expecting to see two type 3 LSAs. And we've got two network segments in the EIGRP autonomous system, the one between R1 and R2, and the one connecting from R1 to SW1. So I expect to see two type 5 LSAs, but we just have one ASBR, router R2, so I predict we'll have one type 4 LSA to point us to the ASBR of R2. And on router R5, we can do a show IP OSPF database command, and we can see all the LSAs. For router LSAs, the type 1 LSAs, as predicted, we have two, one for each segment in Area 0. For the type 2 LSAs, we only had one qualifying network segment, the one between R4 and R5, and we see that. For the summary LSAs, these are networks available in Area 1. We see these two networks. They are available in that other area, Area 1. And in order to get to the EIGRP autonomous system, Area 1. And in order to get to the EIGRP autonomous system, we have to know how to get to the ASBR that gets us there. And here is the IP address of that autonomous system boundary router. And here's the advertising router, R4, our ABR, that can get us to the ASBR. And we had two network segments in the EIGRP autonomous system. We had network 192.0.0.0 and 192.168.1.0, and we see those present in the link state database as well. And that's a look at some common OSPF LSA types.